What is a star's apparent versus absolute brightness? Imagine looking up at the night sky and seeing countless stars twinkling. Some seem brighter than others, but what makes one star appear so dazzling while another looks faint? That's where understanding apparent and absolute brightness comes into play. When astronomers talk about how bright a star looks from Earth, they call it apparent brightness. It's influenced by how luminous the star truly is and how far away it is from us. Think of it like a flashlight. If you hold it close, it looks very bright. If you move it far away, it appears dimmer, even if it's still shining just as strongly. The farther a star is, the less light reaches our eyes, making it seem fainter. Now, absolute brightness is a different story. It's a measure of how bright a star actually is, regardless of how far away it is. To make comparisons fair, astronomers imagine placing every star at a standard distance of 10 parsecs from Earth. A parsec is about 3.26 light-years, so 10 parsecs is roughly 33 light-years. When a star is at this distance, its brightness is called its absolute magnitude. This way, astronomers can compare the true power of stars without the distance messing with the numbers. Here's a simple example. Picture two stars. One is very bright but far away, and the other is less bright but close. They might look equally bright in the sky, but their true brightnesses are different. The distant star might be shining brighter than it appears, but because it's so far, it looks dim. The closer star might seem brighter, but it doesn't emit as much light overall. The scale used to measure brightness is called the magnitude scale. It's a bit tricky because it works backwards. The lower or even negative numbers mean the star is brighter. For example, the Sun has an apparent magnitude of about -26.7 because it's so close and bright to us. Its absolute magnitude, however, is about 4.8, which shows how luminous it really is if it were placed at 10 parsecs away. Knowing the difference between apparent and absolute brightness helps astronomers understand the true nature of stars. It allows them to compare stars fairly and measure how far away they are. This is essential for mapping the universe and understanding how stars evolve. Think of it like a car's headlights. When they're far away, they seem dimmer, but their actual power doesn't change. It's just how they look from where you stand. In summary, apparent brightness is how bright a star appears from Earth, depending on its true brightness and distance. Absolute brightness is how bright it truly is, standardized at 10 parsecs. The magnitude scale makes it easy to compare, with smaller numbers indicating brighter stars. Recognizing this difference helps us unravel the mysteries of stars and the universe around us. It's a key idea that makes exploring space so fascinating and helps answer many questions about the cosmos.